Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. I'm going to start just by writing down the number. And we're asked to round this to three significant figures. And basically what that means is starting from the left-hand side, it's three numbers that we want. So 1, 2, 3. And we're going to do our line after that third number. And you start counting the first non-zero digit. So the first digit there was 2, so we started counting. Now all the numbers to the left, or sorry, to the right, so these numbers here, will all turn to 0. But before that happens, we look at this number. Now this number, if it's 5 or more, it moves this number up by 1. If it's less than 5, that number stays the same. Now it is 5 or more, because it is 5. So it's not going to be 207, it's going to be 208. Now, a common mistake is that students write down 208. No, all the numbers to the right of that line turn to 0. So it would be 0, 0, 0. So it would be 20,000 or 208,000 exactly. If we tried to draw a quadrilateral with a pair of parallel sides, and then it's a quadrilateral, so join them up, it's got 4 sides, then the shape we draw will always be a trapezium. So our answer is that it is a trapezium. Now you might think that a rectangle and square does have one pair of parallel sides, but it actually has 2 pairs of parallel sides. The definition of a trapezium is it has just one pair of parallel sides, and any quadrilateral that has one pair of parallel sides is a trapezium. So we're going to find out the multiplier first, and we do that by starting with 100%, and it says it increased by 11.2%, so we're just going to add 11.2%, which will give us 111.2%. Then we're going to make that into a decimal by dividing by 100, and this will make it into a multiplier, so it's 1.112. That's our multiplier, and the beauty of a multiplier is all we do is we get our amount, which is 840, and multiply it by the multiplier, and it will do all the hard work for us and give us the answer of 934.08. So for this question, we need to understand that the units we currently have are in meters per second, and the units we want to get them to or convert them to are kilometers per hour. Now to convert the meters part is quite easy, because all we need to do is divide by 1,000. And when you divide the top of a fraction by 1,000, all you do is you just divide the whole thing by 1,000. So we're just going to divide the whole thing by 1,000. So we've got 95, and we're going to divide the whole thing by 1,000, so we get 0.095, and that's going to be kilometers per second, because we haven't dealt with the seconds yet. So that's the easy part. The more difficult part is converting the seconds to hours. So to convert seconds to hours, we divide by 60 and then divide by 60. So we divide it by 360. Seems simple enough. But the seconds are at the bottom of a fraction, and when you divide the bottom of a fraction by something, you actually times the whole fraction by that thing. So we're going to times the whole fraction by 360. And so we do 0.095 times 360, and you get the answer of 342 kilometers per hour. So our answer is 342 kilometers per hour. So there's a formula for percentage increase or percentage change, and it is the change over the original amount times 100%. So to find out the change here, we're going to do the difference between 1421 and 1100. So we're going to do 1421 take away 1100, which is 321. Divide that by the original amount. So the original amount was the 1100, and then times by 100%. And that's going to be 29.18%. Rate is always something over time. So in this question, we can work out the rate as being the pay, or the final pay, or whatever, over time. Now we're asked what the time is, so we're just going to put the time on the left hand side, and we're just going to swap the rate and time over, so it would just be pay over rate. The pay is £180. The rate is £12 an hour. So it'd be 180 divided by 12, which is 15. So it'll take 15 hours. We've got to first of all work out how many parts there are altogether in our ratio. So we've got 51 saying yes, 7 saying no, and 13 undecided. So altogether, we've got 51 plus 7 plus 13, which is 71 parts. Now each part is equal. So to find out the value of one part, we're going to do how many students there are, which is 2,911, and divide it by the 71 to find out what one part is worth, how many students are in one part. One part's worth 41 students. So each one of those parts in the ratio is 41 students. Now yes, because it goes yes, no, undecided, yes will be the 51 there. So it's 51 lots of 41 students. 51 parts with each part representing 41 students. And when you multiply those together, you get 2,091. So our answer is that 2,091 students responded with yes. The first thing we need to do is work out what angle CBD is. So we're looking for angle CBD. And that's going to be 180 take away 170. And the reason being is its angles on straight line. Angles on straight line add up to 180. So that's going to be 10 degrees. So this will be 10 degrees. We then need to find out what angle CDB is. And this is obviously going to be 10 degrees as well because its angles is an isosceles. So this will be 10 degrees, and the reason will be that it's an isosceles triangle. And to find out what x is going to be, it's going to be 180 subtract 10 plus 10. And the reason for that is its angles in a triangle add up to 180. So that's going to be 160 degrees. Make sure you state your reasons for every step of the working out, because there's normally quite a few marks for the reasons. So we're asked to find the value of n where both sequences have the same term. So I'm going to start off by equaling both nth terms to each other, and then we can find the value of n which gives the same term. So I draw my lines down, and I'm going to start off by getting rid of the n's from both sides. So we look to see which is the smaller amount. So we've got 12n and we've got 6n, so the smaller amount is the 6n. So we're going to take away 6n both sides, and so that would be 6n plus 19. And we've got rid of the 6n, so it's just 79. Next thing we're going to do is get rid of the 19, so take away 19 both sides. And so we've got 6n equals 79 take away 19, which is 60. And finally, we just go divide the 6. And so that'll be n equals 10. So the value of n is 10. Now we can just test this, because if you do 6 times 10, which is 60, 60 plus 79, which will be 139. And then if we do the same for the top one, 12 times 10, which is 120, plus 19, which is 139. So they both have the same term when n is 10. The formula for an exterior angle for a regular polygon is 360 divided by the amount of sides. Now here we're given the fact that the exterior angle is 30 and we're looking for n, so we just need to rearrange the equation. We can times both sides by n. And then divide both sides by 30. And so we've got n equals 360 divided by 30. And when you do 360 divided by 30, we get the answer of 12. So it's a 12-sided shape. So if we imagine we've got the 25-meter pipe here, and we've got the 35-meter pipe here, the question's basically asking us what can we cut all these pipes into, and they all have to be the same length, that will fit with the 25-meter and the 35-meter. And essentially what this question is asking is, what is the highest common factor of 25 and 35? So to find the highest common factor, what we do is we just find the factors of 25, which is 1 and 25 and 5 and 5, and the factors of 35, which will be 1 and 35 and 5 and 7. And the highest common factor is the number in both lists, the highest number in both lists, so it's 5. So what we can do is we can cut all of these pipes into 5-meter pipes. So 1, 2, 3, 4, not to scale, and then 7 of these, so 1, 2, 4, 5, 6. And so there's 7 in total. So each of these are 5 meter long, and there's no wastage. And that's the longest we can make the pipes for there to be no wastage at all. So my answer is 5 meters. So we're given 21 to 4 is the ratio. We're just going to have our lines in, because what we need to do is make the left hand side be 1. Okay. And to do that, for 21 I need to divide it by itself, divide it by 21, and we're going to do the same to the right hand side. So 21 divided by 21 is 1, perfect, that's what we wanted. 4 divided by 21 is 0.190 blah blah blah. It says it wants it to 2 decimal places, so it's going to be 1 to 0.19. To answer this question, I'm going to do a quick number line, and I'm going to put the 12 meters on my number line, and I'm going to think what the next number down would be that it could have rounded to. Well, it's 10 to the nearest meter, so the next number it could have rounded to is 11. And to find the minimum it could have been before rounding to 12, all we need to do is find the halfway point between 11 and 12, which is obviously going to be 11.5. So our answer is 11.5 meters. So in this question, we've got a right angle triangle, and we're asked for length BC, and we're given the other two lengths. It's going to be Pythagoras. And so for Pythagoras, I just label the sides A, B, and C, but C must be the one opposite the right angle. And Pythagoras says that a squared plus b squared is equal to c squared. We don't know what a is squared, but we know what b is, which is 5.2, and we know c is 11. So when we do that, we get a squared plus 27.04 equals 121. And we just solve. So the first thing I'm going to do is take away the 27.04 from both sides. So we get a squared equals 9 93.96. There we go. And to work out what a is, we just square root both sides. So it'd be a equals 9.693 blah blah blah. Asks us to do 2 decimal places, so we write 9.69. When translating, we translate with vectors, and the top number in a vector tells us how far right, and the bottom number tells us how far up we go. And to translate a shape, you always pick a point. Now I always pick the top leftmost point, so I'm going to pick this one. And looking at the vector, it says we're going to go 2 to the right. So we do 2 jumps to the right, 1, 2. Now looking at the bottom, because it's minus 4, instead of going up 4, we're going to go down 4. So it would be 1, 2, 3, 4. So our new coordinate for the top will be here. And the next thing we need to do is draw in the shape. So that's the top left part of the shape. And so I'm going to draw in the shape, and it's 4 across. So it should go here. And draw in the shape in there. Make sure that you know that that coordinate is the top left part of our shape. And it says to label it B. So we're going to start off with x equals 0. And we're going to write out this equation, but with 0 every time it says x. So it's going to be y equals 0 squared minus 0 plus 10. Well, 0 squared is just 0, so 0 take away 0 is just 0, plus 10 is just going to be 10. So the answer there will be 10. Do the same for 1. So it will be 1 squared minus 1 plus 10. Well, 1 squared is 1, 1 take away 1 is 0, plus 10 is 10. So that will also be 10. 2 squared minus 2 plus 10. 2 squared is 4, 4 take away 2 is 2, plus 10 will be 12. Now we're going to do the negative, so we're going to look at minus 1. So it's y equals minus 1 squared, and it's going to be minus 1 plus 10. So a little bit more complicated here. Minus 1 squared is just 1. Now here you have 2 negatives together. When you have 2 negatives together, it makes a plus. So we've got 1 plus 1 plus 10, which is going to be 12. And then we'll do the minus 2, so it'd be minus 2 squared minus 2 plus 10. So minus 2 squared is 4. The 2 minuses here make a plus, so it'd be plus 2, which would be 6, plus 10 will be 16. So we're going to plot these on our graph. And so we've got minus 2 is at 16, so that'll be there. Minus 1 is at 12, which will be here. 0 is at 10, 1 is at 10, and 2 is at 12. Okay, when you join this up, things to be aware of is you need to make sure that you have a round U at the bottom and not a flat bottom. Okay, so you want to avoid a flat bottom. You also want to make sure that you avoid feathering like that. You want just one nice smooth line. And my recommendation is always to turn the page on its side. I don't have that luxury, so I'm going to try my best with this. But you need to make sure it goes through all the points. And here's the part here where it goes beneath those 2 points. So make sure it goes beneath those 2 points. On most exams, I see them, basically what they do is they draw a line across from those 2 points and say that the line needs to go beneath that, or your curve needs to go beneath that line. So they're looking out that you've gone beneath the line. The formula for the area of a circle is area equals pi times r squared. Now in this question we're given what the area is, which is 706.86. And we need to find out what the radius is. So I'm going to get my lines in. And I'm going to start by getting rid of that times pi. So I'm going to divide both sides by pi and get the r squared on its own. So when I divide that by pi, I get 225.000 blah blah blah. Very close to 225. Then I want to get rid of this squared here. So to do that, I do the inverse, which is square root. And square root of 225 is 15, and the square root of 225.000 blah blah blah, whatever was in our calculator, is going to be 15.000, etc. So pretty much 15. 0.000, but it says it wants it to the nearest integer. Integer is a whole number, so my answer would be just 15. When working out if two triangles are congruent, which means they're the same, you can either have RHS, which is a right angle hypotenuse side. You can have three sides that are the same. You can have two angles then a side, or an angle then a side then an angle, or you can have a side then an angle then a side. In this question, we have a right angle. We only have two sides, so we can cross this one out. And if you look, that the two sides are next to each other, then the angle. So it's ASS or SSA. So these don't really fit. But the angle is a right angle. So we've got a right angle on both of them. We have the hypotenuse. And we have a different side that are all equal. So the proof here is RHS. It doesn't look like it, but we actually have a quadratic here. And the reason it doesn't look like it is because we don't have an x term. But as long as we have an x squared term and a number term, we definitely have a quadratic. And notice something about this second number. It's a negative version of a square number, and that will always be the case because this question is using something called difference of two squareds. And it's very, very simple to work out. What you do is you put down two sets of brackets and you square root the first term. Well, that's just going to be x. And you put the positive and negative versions of the square root. So we're going to square root 121, which is 11. So we're going to put plus 11 and minus 11, and that's it. Now, when we expand that, and we'll just go quickly expand that now to have a look, it's going to be x squared plus 11x minus 11x minus 121. And notice that the two x terms cancel each other out, which is why we don't have the x terms. There are two shapes we need to find the volume of. There's this cylinder here and this hemisphere here. So we might as well start with this cylinder. And the formula for the volume is pi times r squared times height. So it's the radius is 9, so 9 squared times the height, which is 30. And when we work that out, we get 7,634.070, blah, blah, blah. Next is the hemisphere. To find the volume of the hemisphere, well, the volume of a sphere is 4/3 times pi times r cubed, but because it's a hemisphere, we just times that by a half. So it's half times 4/3 times pi times r, which is the radius, which is 9 cubed, and that gives us 1,526.814, blah, blah, blah. And so the total volume is 7,634.070, blah, 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 plus the 1,526.814, blah, 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 which equals 9,160.884, blah, blah, blah. It says it wants it two decimal places, so when we round that, we get 9,160.88. So we're asked to express TQ in terms of P and Q. Well, we've got another Q here, because all of these are congruent parallelograms, and we have a P there. So if we're starting at T and getting to Q, we can go along this path here and down this path here. So we're going backwards down Q, in fact backwards down two lots of Q, and then the correct way down P. So it's either minus 2Q plus P or P minus 2q.
You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing.